Now let us study more features of this force of gravitation. Okay, so listen children, I am going to draw that figure once again in a magnified mode. This is mass m1, its center is there, and this is mass m2. They are separated by a distance d that we have drawn it much earlier. So m1 is acting on m2, the force is acting on m2, and m2 is exerting a force on m1. So these forces can be written like this. These two forces are equal and opposite actually. And what all are the features of this gravitational force? The first feature of the gravitational force is, as you know, it obeys inverse square law, isn't it? It obeys inverse square law. What do you mean by inverse square law, children? We know that force is proportional to 1 by r square, right? That is what is meant by inverse square law. That means it is inversely proportional to the square of the distance. Let me give another example for an inverse square law. We know that its electrostatic force is an inverse square law. As the distance increases, what happens is that as the square, the force decreases. That is it. It obeys the inverse square law. And the second is, this points is given in your textbook, but we are going in a compiling mode. It acts along the line joining the two masses. It acts along the line joining the two masses, isn't it? The force I have marked this is along the line joining the centers of two masses. Line, acts along the line joining the centers of the masses. Centers of the masses. Okay. And another point is regarding this, it's a long range force. What is it? It's a long range force. What do you mean by a long range force? This can be manifested, or this effect can be seen in long distances. We know that Earth is revolving around the sun. Why it is revolving around the sun? There is a huge distance, and we can see its effect that Earth is kept along in the solar system, right? And next is, it is independent of the intervening medium. So what do you mean by that? Independent of intervening medium. So what do you mean by intervening medium? That means that when we are placing two masses in air, we are placing the two masses in air and let there be a force between them as F. And if it is as such, with the same distance and the same mass kept under some water inside a bucket, the force remains the same. Whatever comes in between the two masses, it doesn't matter. So these are the important points. It obeys the inverse square law. As the distance increases, force decreases. It acts along the line joining the centers of the masses. Next, it is a long range force. Next, it is independent of the intervening medium. These are the features of Newton's gravitational force. So I hope that you have understood this point. Next, we will discuss the significance of this gravitational force on us, or what is the importance of gravitational force. Why Earth is revolving around the sun due to gravitational force. All the planets are revolving around the sun due to gravitational force. The moon is moving around the earth due to gravitational force. And we know that the tides due to the moon and the sun. We know that low tide, high tide, we see. We know it, right? All the tides that is due to the moon and the sun happening on the earth is also an effect of gravitational force. So that's why gravitational force is very significant to us.